everybody hear me? Is this working? So, good evening, everyone. My name is Sharon Hagi. I'm the Chief Security Officer at Silicon Labs, and I'm excited to be here this evening to talk to you about, the vision and securing IoT. It's a top-of-mind topic, and before I get started, I really wanted to thank the organizers as well as our marketing team and you guys for taking the time to join us this evening. So hopefully you'll find the talk interesting. So I wanted to start by sort of talking a little bit about the company and what we do. We're essentially a semiconductor company, and we build the hardware and software platforms that enable our customers to build connected solutions for the market. And essentially, our product portfolios cover things like broadcast, timing products, isolation products, and so on. But the largest part of our portfolio, about 50% or more of the revenue we generate every year, actually comes from selling IoT solutions to the IoT device makers in both the home automation and the industrial automation space. So, just to kind of put into perspective, we are talking about security, so I like to use economics to kind of illustrate the impact that IoT has on the world economy and the disruption that cybersecurity incidents can potentially cause. So, according to some estimates, including our own, the global GDP is probably going to reach $100 trillion by 2025. So if you kind of look at it, at the IoT economic activity that's going to happen, it represents about 10% of that global GDP. So it's about $10 trillion. And we're talking about everything that has to do with IoT around the world. About $1 trillion of that figure is associated directly with hardware, software, and services, including things like telecom and anything else, including cloud, anything else that is involved in enabling IoT to actually operate. And out of that, about $100 billion is directly associated with our total addressable market in terms of hardware, software platforms. That's the market that we are basically addressing with our products. So in terms of the growth of connected smart devices in the marketplace, you're just basically seeing a trajectory, up and up and up. By some estimates, we're going to see about 80 billion connected devices, connected smart devices deployed around the world. And there is an estimate that I've seen from, I believe, Gartner, where they're predicting that by 2030, we're talking about more than 1 trillion devices. Right? So you just see the scale of problem that we're actually dealing with here in terms of the number of devices and the sheer complexity of getting all of those things connected into our lives and the fabric of society. Right? So both from from an economic perspective, as well as an impact, the societal impact that IoT has. These things are going to be in our bodies eventually. Implantable medical devices. Think about, self-driving vehicles. Think about the sensors and the cameras and everything else that will be enabled by these devices, and the sheer magnitude if something happens to those devices from a security perspective. If there's a breach that impacts, medical devices, implantable medical devices that impact millions of people, that's pretty bad. And that's pretty bad from an impact on people, but think about the economic impact as well. So cybersecurity is starting to be, companies are starting to realize just the magnitude of this problem, and so that's why cybersecurity is now a top of mind issue for a lot of companies in this space, especially companies like Silicon Labs, who are building the foundation in hardware and software that a lot of these devices are actually built on top of. So, you know, if we look at IoT, I mean, you know, these devices are fundamentally created to sense the world and gather data, right? And so what we're really looking to secure are two things. We're looking to secure the devices themselves. We don't want people tampering with devices. Again, going back to my example about medical devices, we want to make sure that nobody can, you know, tinker with somebody's pacemaker, right? That'd be bad. But we also want to protect the data that is sent from those devices to cloud services. I mean, essentially, IoT devices are, you know, almost ubiquitously connected to some cloud application. And so if you think about things like sensors, I mean, they send measurements. We want to make sure that those measurements are authentic, that, you know, somebody can't spoof the data that's coming from a sensor. We also want to make sure that the data that's sent is confidential, because maybe that sensor is measuring some human activity. You know, the fact that we are present in a room, or we're opening a door, or we're trying to navigate somewhere, taking our temperature, taking our biometrics, that data is considered private. We want to make sure that we're protecting that. So, you know, in general, we want to protect IoT devices against tampering, against counterfeiting. We want to make sure that the data that they send and receive from those cloud applications is authentic, that we can verify its integrity, and we can ensure its confidentiality. So that at the core, you know, is what we're actually talking about when we're thinking about the security of those devices. But as you'll see, as I kind of continue sort of talking about this, it's more than that. It's a lot more than that. Because to get that kind of security, we have to think about the problem holistically. We have to think about the problem from a people, process, and technology perspective that really starts with the device but doesn't really end there. It looks at all the different aspects of the problem across all the different layers that are involved in actually deploying an IoT solution and running it and operating it. So if you went to, and this is a survey, by the way, a Gartner survey that, you know, involved a number of top-tier organizations, and they basically went to a number of companies and said, what are your top concerns or technology-related challenges in deploying IoT in your organization? And if you look carefully at this chart, they identified essentially three top issues. The first one is cybersecurity, no surprise. The second one is integration. Integration is a problem. And the third is determining and managing business requirements. So this includes figuring out what the security requirements around IoT should be. So businesses are currently struggling with those three top issues. They're struggling with figuring out how to integrate IoT devices into enterprise networks in such a way that these devices integrate with their existing security systems. The systems that organizations like Fortune 500 companies, like mid-sized businesses, and even small businesses have spent the last decade and a half or more building security solutions, building security management systems, monitoring, authentication, data protection, and so on. How do these devices seamlessly integrate with that existing investment? How does an organization ensure that an IoT device that's running on a network is, you know, permitted to be on that network, is authentic, sends the data, is not compromised by malware? How do you monitor that device? How do you control it in the event of an incident? Right? How do you even orchestrate that? And those are, by the way, the requirements. So those are some of the top challenges that enterprises are currently struggling with. And it is a struggle because when we see the breaches out there, it's evident that, for example, security cameras deployed in many companies that are IP enabled contain the most vulnerabilities. And there's, in some cases, unpatched, and nobody even knows how to secure them properly. And so that leads me to the two types of attacks that we typically see where adversaries actually exploit those devices to penetrate and breach network security, infrastructure security at many companies. So the first is essentially using those weak devices as a gateway inside an organization. Once you can take advantage of a camera, security camera, or a printer, or a sensor that has a vulnerability, and you can implant or you can update the firmware and actually install a Trojan, and that enables you to then move laterally across the organization. You can scan the network, you can find the next target.
An example of that is a while back, the fish tank thermostat in Vegas. Did you hear about that?
Yeah, I heard that there was a fish tank and somebody put it there and then was able to breach that casino.
Yeah.
Yeah.
They got inside their server and everything. I was wondering if you knew more about that.
Not any more than what was published.
They were able to get the customer database coming through the thermostat.
Yeah. I mean, there's a lot of examples. I mean, the thing, for example, Target, which is a massive credit card breach. I mean, it actually started as a HVAC, system vulnerability. There's many examples where a lot of those devices, because of the fact that they don't integrate with vulnerability management, with monitoring, with a lot of the enterprise traditional security apparatus, they're not participating in it, right? They're often left kind of orphaned there. And so they're unpatched, they're very vulnerable, and yet they're connected to those critical environments, and nobody really is paying attention to them, right? So that's really the source of damage. And the other is, as I mentioned, is direct interference with those devices. And again, a lot of the things that we think of mission critical applications. Transportation, think of self-driving cars. I mean, what would happen if somebody interfered with a self-driving car, right? So a lot of those, are obvious. Some of those are not so obvious. There's a lot of jamming attacks against, home security systems where an adversary could take, some kind of a battery-operated sub-gigahertz attack tool, throw it on somebody's lawn, and that attack tool is going to saturate, the sub-gigahertz network with like bogus messages, control messages, and they can disable an alarm system. It's very easy. Right? Those types of attacks interfere with the operation of the device, and it can cascade from there. And what's causing all of that is basically the dramatic increase in vulnerabilities. I mean, we're seeing, and again, you're looking at data that was gathered by or reported by IBM X-Force Threat Intelligence. IBM does a lot of vulnerability research on IoT, and they've been tracking the rate at which companies have been disclosing vulnerabilities. This is disclosed vulnerabilities, or vulnerabilities that have been discovered by their research team. And you can see that since 2014, there's been a 5,400% increase in the number of vulnerabilities. Those are the vulnerabilities that we know about. Can you imagine how many we don't know about, right? And that's really the problem. The problem is that the IoT device makers, and those include our customers, don't necessarily know or don't necessarily focus, I shouldn't say that, but don't necessarily have the right focus and priority on designing and producing IoT devices that are secure, right? And that's why we're seeing this increase in the number of vulnerabilities. And we want to help fix that. And that's why we believe that, essentially, security is core to a smarter, more connected world. I mean, if we don't solve the security problem in IoT, there's a good chance that a lot of the application, a lot of the good things that companies are working on including things like machine learning, right? We hear a lot about the growth in semiconductor companies is actually being driven by a lot of machine learning at the edge, where these devices will have a lot of intelligence. So think about, I don't know, smart door locks that can detect your face without necessarily talking to a cloud service. And the reason for that is because a door lock is probably going to be battery operated. We don't want to have it talking on the network too much because it drains the battery. So we want to be able to do things like inference locally, right? So those are examples of the kind of applications that we want to drive, but they're not going to be possible if we don't fix the security problem first, right? So leading the effort to build security from chip to cloud is basically the mission. This is our mission as well. And we believe that by addressing this at the time of the product's design, all the way through its manufacturing, through to the hands of our customers and how they use it in their design process, how we can help them basically create secure solutions while accelerating time to market. You know, we don't want to have security basically be a burden, a obstacle, right? Something that slows development down. That's the last thing we want. But that's a challenge. How do you address security in such a way that it doesn't slow you down? And by the way, this problem is not unique to IoT. This problem is unique to anything in IT. Even in DevOps, you know, you hear about things like DevOpsSec, where we want to automate the build process of software, and we also want to integrate security testing and security activities into that process in such a way that it doesn't slow the rate at which we deploy builds to production, right? We're talking about, you know, deploying not once a month, but maybe every 20 minutes, right? So how do you secure that, right, as you iterate in an agile process? And we also believe that in order to solve the security problem, it's going to require collaboration. It's going to require collaboration among multiple stakeholders in the ecosystem, and I'll talk about that as well. But it's really important there that we collaborate with government and universities and so on to establish best practices and standards, and even regulate, because it's an important catalyst, if you will, for companies to actually start to do the right thing. So there's really 5 things that I want to highlight in terms of securing IoT that are challenging. The first one is to secure, you know, IoT, it requires high levels of expertise. It's you know, when you're thinking about the cross-section of the IoT device makers, most of them actually don't have in-house the right level of expertise to build the right level of security. They're struggling. And the thing is, that's a requirement to even get started. The second is, it's complex. Security is just complex. It also requires careful integration of hardware and software. I mean, IoT is not like building a server-side application where you have unlimited compute power and you don't really care about how efficient your code necessarily is because, you know, you can just add another instance, right? This is very, very different, and we'll talk about that. Security, you know, some of these devices are devices like wash machines and smart meters and things that actually live in the field for 10, maybe 20, maybe 30 years. And the thing is that the threats of today, even the cryptographic capabilities of systems today is going to be vastly different in 10 to 20 years, right? So we want to make sure that those devices that are out there for 20, 30 years, you know, that we can upgrade the security as much as we can, right? So security for IoT, you know, you got to think about future proofing. You got to think about how do I upgrade security for those devices. And like I said before, it requires a full stack perspective. Full stack perspective. I think a lot of companies today don't have full stack perspective. They're narrowly focused on just the device, just the target device. They're ignoring the fact that this device is operating in an environment where it's connected to multiple networks, there's multiple people involved, there's different processes. It's a people, process, technology issue, and we can't just look at the device in order to solve the problem of how to secure it. So let's talk about the skills problem. A recent ISC squared, anybody know who the ISC squared is? Yeah, okay. So you must be certified, no?
Not yet.
Not yet?
About 5 years.
Okay. So the IC squared is the organization that actually created the CISSP. I volunteer with that organization, and that organization runs yearly workforce studies to see where cybersecurity professionals work and what are sort of the gaps and challenges. And what they found is that globally, there's a shortage of cybersecurity professionals across all industry segments, about 3 million positions. In the United States, about 500,000 positions. So there's an incredible shortage of skills out there. There's no shortage of work. It's just not enough people that understand security. There's not enough people that understand security in general, but there's definitely an even larger shortage of people that understand security at the hardware level and the embedded software level, right? I mean, that is an even bigger gap. And how do we solve that, right? And I think that, it's really, really important when we go back to this whole point about collaboration, this is where we need to collaborate. This is where we need to basically encourage the current and the future generation of engineers, of designers, of professionals to basically take up the curriculum. We need to work with universities to introduce this. And this is, again, not just the classical IoT security problem. This is a problem across the board with security in general. We just don't have enough people who know enough about cybersecurity to help the industry, not just IoT. But this is worse here. This is really bad. We just don't have enough people at all. And we got to solve that. And the way we solve that is together. And we have to encourage certification. I mean, even if you have a security professional, how do you know they know enough? There's got to be a baseline, right? And something like the CISSP was a very good baseline for general IT security. So if you're a professional and you're in security and you want to certify, the CISSP was the no-brainer choice. There were other certifications as well. But we have to maybe create professional certifications around IoT security, right? For hardware people, for software people, for people who develop cloud applications. Like, it's got to be an area of specialization, because it is. So that's one of the things that we got to drive together. In terms of complexity, so it's really complex, right? There's a lot of different things that are involved in building a secure IoT product. So you got to take care of, firmware and real-time operating systems. There is integrated circuits. There is things like embedded secure elements, which drive cryptographic function and security functions inside the chip. And you have to basically have SDKs that call the right function in order to encrypt things, in order to hash things, in order to authenticate, in order to drive all those functions. And it's a complicated endeavor, right? And the thing is that if you don't do it right, it's actually worse than not doing it at all. I mean, security implemented wrong is worse than security not implemented at all, right? And the reason for that is because you got a false sense of assurance. And somebody tells you, my product is secure, but in fact it's not. It's actually worse than somebody telling you, my product is not secure. You'll be careful then. You'll be careful then. You'll take out insurance, you'll be very careful to monitor it and maybe isolate it. But if somebody says, my product is secure, it's a very different requirement from the perspective of what do I do with it? Where do I integrate it? Right? So we have a skills problem with IoT companies that don't have enough skills, and it's really complex. So what we believe the solution is to basically simplify development. Simplifying development, and encapsulating security in the underlying software that IoT developers use to build solutions is actually the way to go. So if you look at it, simplicity is actually what's going to help us drive secure solutions to market, where we make sure that the way the software, the way the system, the way the hardware actually works intrinsically out of the box is in a secure state. Right? So if you're an IoT software developer or an IoT hardware developer and you want to open up a connection to a cloud application, there ought to be an encapsulated way for you to do that, where the underlying mechanisms underneath, call the right hardware function, call the right software function, open up the connection and actually establish that authentication, establish the encryption, and actually send that packet of data to that cloud application in the most secure way possible without you doing a thing as a developer, right? And that's, most customers, actually, that's the way they want to develop software. Very few actually want to tinker with the low-level details, the SDK, the raw code that actually drives a lot of the security functions. There's, of course, a class of customers that we know are still going to need to do that. The Amazons of the world, and the Googles of the world, and the Apples of the world. And that's because they actually have the people and the experience to do that. They don't have, they have people that understand security at that level. And they certainly have the process and the quality assurance and all the things that you need to make sure it's done right. So certainly some companies are going to be in that category, but most companies really need us to develop solutions that are simple and are secure out of the box. You'll keep hearing me say that because it's really, really important. So the other thing is, I was mentioning that developing IoT products, IoT solutions is not the same as developing server applications or even PC client server applications or an app on the phone. Very, very different. And the reason for that is because we have to be energy friendly. We gotta understand that IoT devices are typically dealing with microwatt energy consumption. They have to be there for a long time, and most of them are operating on a lithium manganese battery for like 10 years, 15 years. And so they can't sit there and encrypt tons of data and open connections to the cloud every 5 seconds. I mean, they're just gonna die. So when you're designing a security solution for such an IoT product, you got to be very careful, right? You got to make sure that your implementation is energy efficient, computationally efficient, and certainly it helps that companies like Silicon Labs are embedding a lot of that heavy-duty computational or cryptographic functions inside the silicon itself. So putting a lot of that functionality in silicon not only increases the security and trust in that product, but it also makes it energy efficient. Okay, and that's kind of like what we do. And I already mentioned in terms of security, it has to be upgradable, and the way we make it upgradable is it's very difficult to upgrade hardware once it's in the field. You can only hope to retrofit it, right? But even that's too difficult. So the only thing that you can actually upgrade is the software, realistically, right? But then when we're talking about upgrading software, it has to be done in a way that is secure. The device has to be able to confirm the authenticity of the update package that is being pushed to it to make sure that it's actually coming from a trusted source, right? And we have mechanisms in our products that enable us to do that secure firmware update over the air on a lot of our products, and also do the checking during the time that those products boot up to make sure that we verify the authenticity, i.e. the digital signature on that firmware package prior to the device coming online and starting to operate, right? So that is a very important capability that drives that kind of upgradability. So, you know, a lot of our silicon for IoT essentially encapsulates not just the microcontroller and MCUs that, you know, drive the functionality of the product, but they also include a lot of wireless antenna and wireless circuitry that essentially drives a whole myriad of these protocols. So we call it basically system on chip that combines both the microcontroller as well as the wireless stacks. So with all of these, you know, stacks, you know, I'm talking about things like BLE, you know, some proprietary protocols that our customers often develop, Thread, which is an IP addressable mesh network standard, Wi-Fi, which you should all know what that is, Zigbee, and Z-Wave, right, which are mesh networks, sub-gigahertz networks that effectively are used to connect a lot of the IoT devices and control them. So think about light, you know, smart light bulbs, which I'm sure some of you have in your home, smart thermostats, you know, the Ring doorbell, you know, they all use multiple combinations of these protocols in order to work. And so, you know, again, in terms of securing an IoT device, you got to secure not just the device itself and the way it operates, but also you have to make sure that the implementation of these protocols is secure. Because the wireless networks are the easiest attack surface that an adversary is going to exploit. I mean, they literally have to do nothing. They just basically sit somewhere very close to where the device is and they have free access. They don't actually have to be in physical contact with the device, right? There's a lot of attacks that require an attacker to be in physical contact with the device. So a lot of differential power analysis, side channel, right, where somebody's trying to use methods to actually extract cryptographic keys from a piece of hardware by interacting with it physically, measuring, for example, its power consumption, right? And so that requires you to actually have possession, contact with the device. That's very difficult sometimes. This is very easy, and that's a low-hanging fruit. So we have to basically make sure that we are protecting those protocols as best we can. So fundamentally, all of that has to culminate into a strategy where, you know, we integrate security into the device lifecycle, and it starts with a design. So we believe that, you know, companies have to think about requirements. We call that secure by intent. So that's where, you know, when you're designing an IoT solution, the thought process around what's the threat model that's impacting that solution? What are the vulnerabilities that we should be considering for the adversaries potentially? Today and 30 years from now, right? So we have to have some view to the future. And distill from that the set of requirements that are going to feed into the design and development process, and that's secure by intent. Your device has to be, your solution has to be secure by intent. During manufacturing, we're talking about initializing the devices in terms of anchoring trust within things like silicon, so we want to be able to anchor trust in the hardware, and then leverage that in the software and in the cloud services to make sure that we build that end-to-end trust. And we want to make sure that after or during its deployment and during its operation, the device is operated essentially out of the box in its most secure state, and we call that secure by default. The way the device is configured, the way the device is shipped out of the factory, the way it's connecting to things out of the box has to be secure by default. In fact, we believe that the customer actually has to work hard to disable that. It has to be intentional, right? Just like a internet browser. I mean, can you connect to a HTTPS protected site and not use TLS? No, right? It's very hard. It's very hard to disable that functionality. The browser is forcing you to connect to that website in the most secure way it knows how to do. I mean, could you override it? Sure, you can probably override it, but that website is probably not going to respond because it's expecting you to connect to port 443 using, you know, this particular protocol that you're negotiating, and if you're not going to do that, it's just not going to respond. And if it is, maybe you shouldn't be talking to that website, right? Because it may be compromised. So the idea is just like, you know, Volvo, you know, Volvos, right? Like Volvo in the 1950s came up with the seatbelt in response to an increase in the number of deaths, highway accident deaths at the time, right? And Volvo basically said, you know, listen, we're not going to charge for this as an extra feature. This is important. This is about human life. So even though they had a patent on the 3-point seatbelt, they included it in every vehicle going forward for free, right? And I believe that security should be the same out of the box for every single product, right? It should be part of the product. It should be ingrained in everything that we do around the product, from the way we manufacture and design it, all the way to the way it's operating in the field, right? And that's a philosophical sort of thing that I think everybody, you know, should think about. So, in terms of some of the building blocks that we've actually released to the market, we've actually recently announced our Gecko Series 2 Panther product, which is, you know, our mixed signal sub-gigahertz product, which includes the secure element in the chip. So secure element is a dedicated security processing core that works alongside the MCU microcontroller. And it includes a number of critical features that are used, a number of building blocks, if you will, that are used to then build secure IoT products and solutions by our customers. Things like we have crypto acceleration engine that know how to do, for example, AES and hardware, as well as, you know, secure hashing and public key crypto with elliptic curve algorithms. We have a silicon, I would say, entrenched device identity. That means that every piece of silicon that we make in that product series actually has its own physically unclonable and immutable identity, which we can leverage to identify each and every IoT product out there that we make, right, uniquely, and establish that trust, because that immutable identity is actually entrenched in the way that the silicon is forged in the foundry. It's extremely difficult to counterfeit that or somehow replicate that, because it's just the way the silicon is actually created when it's designed, when it's actually manufactured in the lithographic process. We also have a true random number generator, and that's really important when you want to generate unique and secure keys randomly. Trust zone is a mechanism for essentially running different trust processes within a multi-processing, you know, application. So that's governed by something like a real-time operating system on a device. We have the ability of protecting access to debug. So when a device is out in the field, you don't want somebody basically turning on the debug mode in the device, because that makes it extremely easy for an adversary to essentially control the device, implant malware, or in some way interfere with the operation of the device. So we have created mechanisms that ensure that, at least as far as the microcontroller is concerned, you know, you need to be able to if you need to be able to turn it on because you're an engineer troubleshooting something, you can, and it can be done securely using a challenge response mechanism, but otherwise, this thing is secure. Secure secret storage is a way of actually protecting keys and secrets inside this secure element, secure processing core. So we're able to actually leverage all of the functions there that you've seen to actually create encryption keys that the customer needs for a particular application. Let's say they're creating some application where you need some additional certificates for whatever purpose, right? Different keys. Maybe you're creating different trust levels. So you can actually create keys and actually store them and other secrets and store them inside that storage. Secure boot, I already mentioned, is the ability to essentially boot up the device and make sure that everything that's running in that environment is coming from a trusted source, so we can verify digital signatures on firmware. And that happens every time the device is powered up. Every time. And if those signatures are not valid, the device just doesn't come on. And tamper countermeasures, what it's actually referring to is essentially countermeasures that are there to resist tampering with a device from a side channel attack perspective. So side channel attacks are classes of attacks where the adversary, first of all, has physical possession of the device somehow, or is in close proximity, and can use physical measurements to try to infer the operations on a processor in order to extract the key material. So it turns out, and this can be done not just on microcontrollers, but it could be done on classical desktop processors and server processors like Intel, AMD. They're just as susceptible to this. So measuring things like the power consumption of the CPU while it's executing an AES encryption algorithm. Right? It turns out that if you do that, you can look at the pattern and you can literally tell what is happening inside each one of those operations, and you can actually infer which key material, what bytes in the key material were actually processed. Some other techniques even use the humming on transistors and capacitors to do that. And there were some techniques that were even using sound, right? Like somebody can actually put a microphone on your laptop and figure out, what is the key that the laptop is actually computing. So a lot of those things are actually possible. So we actually created some elements of tamper proofing countermeasures, in particular for a class of attack that uses the power measurements on the secure processing core or the microcontroller. And we also introduced features that, if you're basically trying to tamper with the device by heating it or, somehow trying to pry it, those countermeasures will trigger and the device will be disabled. So that kind of describes some of the capabilities of, the hardware in a lot of our products. But like I said, the hardware is just the beginning. And so when you're thinking about building a secure solution, you really have to think about it from a multi-layer approach in an end-to-end perspective. So it really starts with the hardware, but we're also talking about, as I mentioned, things like network encryption and protocol security, and even looking at, and especially actually looking at the cloud application itself, how it handles authentication and access to data, who's managing it, how is it secured, all the way to the really interesting stuff where you're looking at analytics and automation and data management, and this is where you're looking at, so how do I manage privacy across all of these things, right? So it's a multi-layer approach, and it's really anchored in the hardware, because that's where, we have the physically unclonable root of trust, right? But it transcends all of those layers. And that has to be the scope and perspective of anyone designing a secure IoT solution. So in terms of our collaboration, so we're, of course, a chip designer, and within the technical community, there's a lot of partnerships and a lot of collaboration in terms of coming up with product features and solutions, like simplifying the complexity and making things as easy as possible, but that's not gonna be enough, right? We have to collaborate with our customers. We gotta be able to teach them and to sort of, lead the way in terms of helping them build secure IoT products and solutions. And we also have to collaborate with the cloud providers, because that's where most of the software is actually running, and that's there's a lot of focus on that. Of course, from an end user and an enterprise perspective, I mean, those are ultimately the consumers of those products. So think about the home user. How do they know that the product is secure, and what do they have to do to operate that, secure thermostat or that Alexa in a way that, is secure? And ultimately, we want to also include collaboration with universities and researchers, even the open source communities, right? I mean, a large portion of the software that we actually build all of these solutions is based on open source. So the open source community is very much part of the solution. So we got to start talking to them and contributing and working within open source projects. There's also a lot of security, and of course government. There's a lot of dialogue that's happening today with government and agencies around the world, and there's also a lot of thinking from government as well, because they view this as a problem that that government might be interested in solving through regulation. So as a key takeaways is that security is really, really important to the success of the IoT industry. Without security, we're not going to go very far. Securing the devices is challenging, it's necessary, and we're leading the way. Silicon Labs are products that are secure by intent, secure by design, and delivered to customers secure by default. It's a shared responsibility, and so that's why I'm glad that you guys are here, because I think that delivering that message is part of that. The more people understand, the more education is out there, the more we can do to help each other basically address this problem. And so that's essentially the end of the talk. And we have time for questions.